All right, hi folks. This is Larry Maslino. I wanted to show a worked out example of a problem from Module 2, Assignment 1. And so there's a few problems like this that ask you to find mass when you're given a mass density function. So this function here, called rho of x, is the mass density. Now notice this is a circle, right? This is a plate with a radius of 3. So there's a formula here. If you want to know the mass, it's going to be the integral. And the bounds are going to be from 0 to 3, because that's the radius, 2 pi x times this density function. So I'm going to work out this integral. Let's get started. So it's going to be the integral of 0 to 3, 2 pi x. Let me plug in the density function. They're giving us a little bit of a messy function because of that exponential. 5 plus e to the 3x squared dx. All right, well, let me take a little bit of a time out here and mention U substitution. So there's a method that you may have covered in Calc 1 called integration by U substitution. And let's work it out here. So the integral of, let me just work out x e to the 7x squared, let's say. All right, so how do I work out this messy integration? Well, one thing you could do is let u, because what I'm trying to make this look like is the integral of e to the u du. The reason I want to make this look like, I know the integral of e to the x dx is e to the x. You remember that from Calc 1. So the integral of e to the u du would just be e to the u. So I would like to get this e exponential here to look like e to the u. So I'm going to let u equal 7x squared here. In u substitution, what you do is you take the derivative, du dx. Well, du dx would be 14x. Now you solve this little equation for dx. So I'm just going to do a little algebra here and rearrange it so that dx is du over 14x. All right, now I go do a u substitution. I take this original integral and I write it as the integral of x e to the u, because we just let this 7x squared be u. In place of this dx, I'm going to drop in du over 14x. Well, if you notice, the x's cancel out. There's an x top and bottom. So that's going to cancel out. So this x cancels out with that x. I have a 14 in the denominator. I'm going to pull that out in front of the integration sign. So it's going to be 1 over 14 integral e to the u du. But I know the integral of e to the u du. That's just e to the u. And I still have 1 over 14 in front. And last step is you substitute back for the u. So this is going to be 1 over 14e. Remember, u is 7x squared. 7x squared. So this is called u substitution. And that's what we're going to use here in our example. So in our example, I'm going to let u equal 3x squared. Du dx, the derivative is 6x. Now I want to solve this equation for dx. Let me do the steps here. So what I'm going to do is I'm going to multiply both sides of this equation by dx, because this dx will cancel out with that dx. And I'm left that du is 6x dx, but I want to get this equation solved for dx. So now I'm just going to divide both sides by 6x. So I have that dx is du over 6x. All right, so let's plug in here. So it's going to be the integral 0 to 3, 2 pi, x, 5 plus e to the u, because remember, we let u equal 3x squared. And out here, I'm going to replace this dx with du over 6x. Well, notice the x's cancel out. So this x on top is going to cancel out with this x on the bottom. All right, let me move. I'm going to take 2 pi over 6 and move it out in front of the integral just to make the integral a little less cluttered. And so we have the integral from 0 to 3 of 5 plus e to the u du. Well, now this is an easy integral for me to work out. The integral of 5 is just 5u. The integral of e to the u is just e to the u. And I'm going to make this pi over 3 out in front. And we're going to have to evaluate these, evaluate this from the limits x equals 0 to x equal 3. And I'm intentionally writing the limits as x equals 0, x equal 3, because I want to emphasize that you can't plug these limits in yet, because I got to substitute back and get rid of u and replace it with the x expression. So let's do it. Remember, in our example, u is 3x to the squared, so this is going to be 5 times 3x squared plus e to the 3x squared. And we have to evaluate this from 0 to 3. All right, I'm ready to plug in. So let's plug in x equal 3 first. So it's going to be 5 times 3 times 3 squared. Might as well write this as 15. Let's write this as 15. So let's get rid of this. It's going to be 15 times 3 squared plus e 3 times 3 squared. Now we have to subtract when we plug in the lower bound, x equals 0. So let's plug in x equals 0. So that's going to be 15 times 0 squared plus e 3 times 0 squared. All right, let's clean all this stuff up. So this is going to be pi over 3. Here is 15 times 9. 15 times 9 is what? 135? Yeah, I think 135. Plus e. Let's see here. 3 squared is 9. 9 times 3 is 27. That's e to the 27. Subtract. Let's see. This is a 0. And this is a 1, right? Because this is going to be e to the 0. And e to the 0 is just 1. So here's our final answer. Pi over 3. We have a 135 subtract 1. That's 134 plus e to the 27. Now, I'm not going to work this out on my calculator. By the way, this is a huge number. I'm instead going to leave my answer like this. So I'm just going to leave my answer like this. This is the final answer. And I think the instructions said, give an exact answer. An exact answer means you can't work out pi, or you can't plug in decimal approximations here. You have to just leave the answer as is. So this is the final answer for this. All right, hope this is helpful as you're working in Module 2. Please let me know if there's any questions.